Good day, I'm Dr. Michelle Erasmus. I'm a lecturer at the Department of Mathematical and Physical Sciences at the Central University of Technology in the Free State, which is in the center of South Africa. I'm presenting on behalf of myself and my colleague Dr. Conradie from the iGym in equipping students with a real-world problem-solving skill in the mathematics class. The inclusion of the innovation assignment in the maths class comes from students asking, why must we solve X? This originates from the fact that other engineering subjects are applicable, but maths is perceived as a standalone subject as it doesn't address an engineering problem as such, but rather the techniques required in doing so. Students are, for example, taught how to differentiate and integrate, calculate a Fourier series or a plus transform. All these are wonderful mathematical tools, but they are not shown where it is used in practice. So in answering this question, students are reminded of the processes involved in problem solving in general and not just in the mathematics class. You first of all have to identify a problem. You need to choose the correct tools from a basket of experience. Now, for instance, the ability to differentiate and integrate, Laplace transform and the Fourier series. These might be, again, what is required in the basket of another subject. You solve the problem, and of course you need to evaluate the solution's viability, something that's very important in the engineering field. We subjected students to the thinking processes that were now described before, and also in trying to address the question, why must we solve X? By incorporating an innovation assignment into the maths syllabus together with regular maths assignments. The inclusion will also address the requirement made by the Engineering Council of South Africa that students must comply to problem-solving graduate attribute at exit level. The Maths Innovation Assignment therefore serves as a front-runner to this, where EXA requires the innovation to be directed towards their field of study of electrical, mechanical and civil engineering. The maths is mere a novel innovation exercise, as these students are only halfway through their course. The methodology involved, we piloted this inclusion in 2019, where we aligned the topic with the water shortage in South Africa at that time. Students were given 4 weeks to realize an idea. They could work in groups of 5, and they could consult with myself or with Dr. Conradie at the Idea Gym. Students had to populate a 5-slide PowerPoint template, which had to include the product description and the first 3 milestones of a business plan. Also need to say that students did not have access to any other forms of information prior to this innovation assignment. So the business plan, they had to figure that one out for themselves. Product description, they could come and talk to myself and Dr. Conradie. There was some assistance with the business plan. Dr. Conradie did appoint persons that could address the students, but it was voluntarily. Students presented a total of 20 innovations at the end of this exercise, and it was presented to a panel containing engineering staff and industry. Students had to do the presentations themselves using their PowerPoints, and the presentations were graded by the panel, and the mark contributed 10% towards the course mark. Must also put in at this point that the panel also graded the innovation itself at this point, and not only the management of it. In 2020 and 2021, the topic was aligned with refuse repurposing and interventions for those living with special needs, but as it was locked down and limited access to the internet was experienced by most students, and they also could not access each other, students were given an alternative assignment that they could also do another mathematics assignment instead. All the students chose the additional mathematics assignment instead, and no innovations were submitted. With the return to campus in 2022, the topic was aligned with improving an existing everyday product, which was very relatable for students. They were told to identify a product in their everyday lives that can do with re-innovation. Examples such as the umbrella was given, and a roll of sellotape. We've all had problems finding the beginning of the tape. Students were given 4 weeks to realize an idea. Groups of 3 were allowed, or they could do it individually. They could consult with myself and Dr. Conradie, but as an addition, They were also given access to the product development station and the Center for Sustainable Smart Cities on campus. The students had to populate a 5-slide PowerPoint again with the product description, same as before, but this time we wanted them to also compare the product with other similar products, either via, and also state whether theirs was different or how theirs was different, and if it was a financial difference or a construction difference. The 3 milestones for the business plan was reduced to only the first milestone because we could see from the previous management that students did not have the necessary skill to do a proper 3 milestone plan. Students submitted the PowerPoints containing over 100 novel ideas. This was a very lucrative topic students that could associate with this topic. Myself and Dr. Conradie graded the PowerPoints, which counted 10% towards the course mark, but we only graded the management of it and not the innovation itself, as it was regarded as being a little bit unfair to innovate a product within 4 weeks. So it was all about how the students described the product, how much effort they put into that, etc. After the grading, the innovation assignment was completed and students moved on to other assignments. But the best 10 products, the students with the 10 best products were asked if they would, on a voluntary basis, would like to enter their products or their innovations into a formal competition. They were also given presentation skills so that they would be able to do this on the right level. As we saw in the previous years, that students battle with presentation as such. So they were given help in this regard. Also, they were told that if they did forward their products, that there would be a money and pocket reward for the winners, as well as furtherment opportunities. And all these made students very excited about the prospects. They all 10 students whom were asked if they would continue did. In 2023, we perfected the recipe even more. We did exactly the same thing as in 2022, but we made the visits to the technology station, the PDTS and the CSSC compulsory. In 2022, it was not compulsory. It was placed there to help students to be able to do a better product development, financial, in managing the first milestone, and so on. But it wasn't compulsory. These were things that they could explore. Because we saw once again with all the innovations submitted in 2022 that there is a problem with the aspects of calculating costs, how to prototype a product, how to draw a product, all these aspects, we decided to make the visits compulsory, and also they had to include in their slides, in the PowerPoint slides, evidence that they did attend these sessions. It also served another purpose. Students were also made aware of the facilities available on campus for product furtherment and project management, etc. What were the lessons learned in or since 2019? First of all, it must be compulsory to enforce student compliance. As soon as it wasn't made compulsory during the COVID years, no innovations were submitted. Students must be able to associate with the topic. It must be a fine blend between free thinking with a focused output or creativity within boundaries. And of course, since they're not engineers yet, novel innovations must be expected. Compulsory knowledge tools, the Idea Gym, PDTS, CSSC, it is important that students have a background, that they know how to price products, how products are made, what the processes are that's involved, etc. Assignments must be graded on their academic management, not their innovations, and there must be a money and pocket incentive for winners competing, those that voluntarily give their time to enter the official innovation competition. And of course, there must be furtherment funding. All these things contribute to students complying quite happily to an innovation assignment. At the end of the assignment, we conducted a student survey, also something that students don't do unless it is made compulsory. So before the assignment grades were released, students first had to partake in the in the survey. 143 students took part in 2023, and these were some of the questions that they were asked. How did you source an idea in your innovation assignment? A very large component said, as a member of a group, we shared ideas until we found a suitable project. What was the most difficult aspect? And of course, it was estimating cost as expected. And do you believe your innovation has the potential to go further? Overwhelmingly, yes. It is very important that a student believes in his innovation. Did the innovation assignment change the way you think about products? Yes, I will be thinking of ways of improving existing products or create better ones. The awareness is very important. Problem solving in general requires a set of tools, either classroom theory or life experience. Knowing the right combination of tools is address a specific problem is where a different type of thinking is important. What is this different type of thinking? They could mostly associate with the free thinker. Think it is the ability to visualize a problem which leads to the identification of the right combination of tools. If you could have had a crash course in one of the following skills, which one do you think would have been most applicable to your innovation? Interesting enough, computer-aided design, followed by 3D printing, marketing, and pricing. So how will we improve on our recipe in 2024? From the survey, we will definitely include in the next run a compulsory computer-aided design course. Also, from visits to the PDTS, from the questions students asked, a short course on how to operate a 3D printer will also be a very nice thing to include for students, and also a useful skill that they will have afterwards. So in conclusion, when the mathematics department creates avenues for problem solving, the idea gym creates avenues for solution realization. Students will probably forget about the Fourier series and the Laplace transform, but they won't forget the innovation experience, and they might one day very much rely on this skill. Thank you very much from Dr. Conradie and myself, and I hope you enjoyed this presentation.